So now we're going to move over to the part of the forum where we have our guest speaker. I'm delighted to welcome Ken Luebeck, CMILT, so member of the US chapter of CILT North America. Ken is kindly going to give us a talk about safety management systems. We'll look at this in terms of the transit industry specifically. Ken, I am grateful for you taking the time to put this together and giving us this talk. And also, I'm hoping I've left you some time to answer some Q&A at the end as well. So, Ken, I will hand over to you.
Okay, well, good evening, everyone. Today, we are going to talk about safety management systems from an engineering perspective and in the specific context of U.S. Federal Transit Administration regulations. Now, if you're not an FTA regulated organization or aren't supporting one and just don't care a lick about what the FTA is doing, that's fine, because the principles are generically applicable. In fact, I imagine the airline presentation that's coming up with CILTNA coming up, it will, at least the person doing that is involved in some of these kind of processes, even if that's not part of the presentation. Before I get into that, I'll give just a brief overview of the firm I work with. I now work with Benesch. We're a general engineering firm in the U.S. and Canadian market. We'll build your hospital, your school, your highway. We're probably most known for our railroad division. We have nearly all of the Class 1 freight railroads in the U.S. as customers and as like major customers. The thing we've done most recently that you've heard of was actually a highway project. We're the ones who figured out how to reopen I-95 in Philadelphia in 2 weeks after that tanker truck incident. Someone in our firm knew about a very lightweight fiberglass fill material that was light enough to not crush underground utilities, sewers, that kind of stuff, and put a bunch of that stuff in the hole where the bridge was between retaining walls, and 2 weeks later, the road's open again with enough space to build a replacement bridge. My own role with Benesch is I'm starting a systems engineering practice, among other things, and that this here ties into that. So if I was going to present about SMS to many transit agency executives, pretty sure they'd say, why is a PE, why is a licensed professional engineer presenting on SMS? Everyone else who talks about this is like operational safety consultants and that kind of thing. Like in many transit agencies, you might go from being a train operator or working in the control center to working as a safety supervisor. And those jobs have a technical side to them, but they're not engineering jobs, obviously. If I was talking to agency executives, I'd also be asking them what they've heard about SMS, because all of them are under a mandate to adopt SMS. In fact, they should be there already, but they were still trying to more fully transition. What concerns or fears do you have would be a good question. And anything you're looking forward to, because there's been a lot of hesitation in the industry. Why would we do this? Well, there's an upside to SMS. If your company is trying to adopt an SMS system from scratch with no particular system safety background, it will indeed be a culture change. It doesn't mean you're moving from a bad culture into a good culture, but it will be crossing the pond, as we say, learning from other cultures and bringing some of that back to adapt into your company. Historically, most of the U.S. transit agencies, especially like the newer light rail agencies, they view engineering primarily as technical contract management. Like if you're a staff engineer, that's what you're doing. You're doing contract management of engineering contracts. And this is certainly a role of an engineer. I do a bit of that in my current role for Benesch right now with one of the Class 1 railroads and grade crossing projects. But to understand what engineering really is, we need to go back to 1937. What's now called New London, Texas. That was a place to be in 1937. They decided to build, there's an oil boom, I should tell you. So it was boomtown, even though the rest of the nation was in depression for the most part still.
Hey, Ken, I just checking. We shouldn't be seeing the different slide now, should we?
Not yet. Not
okay,
yet.
all right.
Yep.
Okay.
Not yet. It was a place to be. It was a boom town. And oil, well, they had decided to build a new school, which was enormous by the standards of the day, for all the families that were moving into town to support this oil boom. Such was the nature of how things were done in oil fields in those days. They had this natural gas that they couldn't commercially use, so you'd pipe it off somewhere and flare it to get rid of it. But the general public was allowed to tap into those waste gas lines. So that's how they heated the school. Well, of course, the pipe from there ran into an unvented crawl space that was underneath the whole school. As you might know, natural gas is odorless and colorless. The reason you think you can smell it is because we put methyl mercaptan in it, and that's an odorant that, at least in small quantities, is dangerous to you. So we think anyhow. And that's the smell. Without that, you couldn't tell. Your house would be full of it. You'd have no idea. Well, there was a leak. A lot of kids reported headaches, but no one had any idea what was going on with the school. And then one day there was a spark. This is March 18th, 1937. And you ended up with this horrific scene. Walter Cronkite was a rookie reporter. And if I have my history right, this was either his very first or one of his first assignments as a rookie reporter for the Dallas Morning News. I'm going by memory from that. If I have a slight detail wrong, my apologies. But he did go and see this scene on about an hour or so east of Dallas. And he called it the worst scene he'd ever seen, to include worse than anything he saw as a war correspondent in the various wars that he kind of became famous for being a correspondent before he went on to anchor the CBS News. Why do I bring this up? Well, obviously not every failure of engineering causes this much destruction, and obviously very many lives lost, very difficult scene. The reason I bring this up is the Engineering Practices Act in Texas was drafted and passed as a direct result of this law, of this incident. And that is why we have professional engineering as a licensed profession in the United States. And that's kind of the basis of defining it as a profession in this sense. So that's where it came from. And my point of this is, and the engineers in this group all know this, engineering is primarily about safety. If there's not really a safety component to something, then probably you don't need an engineer, whether you're designing a factory or an airplane, or you have some other kind of operation. Now, on the more positive side of destruction, if you are managing your company, you're on the executive management. Many of them talk about silos in your organization. Well, a properly functioning SMS system will tear down all the silos in your company and turn you into a unified whole. Or maybe you might look at it as the silos are still there, but they're interconnected really well, so you can work together. Everyone knows their role. They know what they can do themselves. They know who to talk to and who you need to talk to get something else done, knows they're supposed to serve this customer. It's all very well defined. Kind of the ultimate systems integration of your whole company if you really wanted to go into SMS. Now, SMS came out of the aviation world, obviously, back in the 90s, if I have my history right. They realized that if we kept the same safety rate we have now, with the growth in air travel, we'll have a major jet crash every week somewhere in the world. And that was the safest form of travel in the world, coming to that conclusion. Arguably, like Amtrak might be in that situation. Whether they're able to go and grow the way they think they will is an open question, but say they did, you have that many more passenger trains running with today's safety. Just because you have more of it, you'll have more crashes. So this came out of aviation. The Federal Transit Administration's take on SMS, they define it in perhaps slightly different terms, but they have 4 pillars, they call it. And I'm going to display these pillars as like a subway map, just so you can tell where I'm at in the presentation. And we'll talk about these pillars two different ways. The first way I talk about them will be very brief, but straight out of the federal regulations. And then then I'll go over it again to talk about in more practical terms, what does that really mean, in your organization? And the four pillars, as you can see, are safety policy, safety risk management, safety assurance, and safety promotion. And that's just what they call them. A alternate way to look at this would be to say safety promotion is really your green field. It's the pasture you live on. We have little sheep in this pasture, and we want safety in our pasture. Therefore, we have a safety policy. The safety policy specifies something called safety risk management. You might call it hazard management, sort of the same thing. And then you have an assurance process to make sure that your risk management process did what you thought it was going to do. And those last two steps form an endless cycle that persists forever, at least until you decide to move to a new pasture. I'll stick with this one today because this was originally made for a transit audience. And these four pillars come straight out of 49 CFR 673, paragraph 21. And that's just an introductory paragraph. The next paragraph is 23. They don't use even numbers. It has these four bullet points on it. You need to define safety objectives as part of your management policy. You define a process to report safety conditions. You communicate it to your whole company, your whole agency. And as with anything you want, if you want something to get done, you need to define who's responsible for what, who has authority, who's supposed to do what. And Section D goes into great length to define things like who's your accountable executive and what does that mean? What's the role of chief safety officer? What are the other key staff? And if we were actually a transit agency, we would dive into that quite a bit to make sure we were set up well. But that's your policy. Once you have a policy, you can do what under system safety was called hazard identification, assessment, and mitigation. And that's its process. We'll dive into that quite a bit today. Once you've done that, you use process control. And this is probably the most important two words in the whole regulation. SMS is about process control. It's not a bunch of boxes you check at the end of a project to fill out what they call a safety certification grid. It's a process. It's a way of life. And that process lets you get data that's relevant, that's performance monitoring. You use that data and other things to define a change management process. And your change management process requires you to go back to the past slide and do hazard identification, assessment, and mitigation. And if you do that cycle well, you reach that glorious state the Japanese would call kaizen, or continuous improvement. Now, the last pillar, the last stop on this subway line is safety promotion. That is things like, how do you know a locomotive engineer is qualified to drive the train, or that jet engine mechanic is qualified to work on that turbine? Those sorts of things, or even presentations like this would fall in this bucket. I'll talk the least about safety promotion because if we do the other three, the needs that your company has for this will be quite apparent and fairly easy to achieve. So in a nutshell, here we have it. SMS is safety policy, safety risk management, safety assurance, safety promotion, and I have, in essence, covered the majority of the regulation, at least as it was last I looked this up, which was some time ago. If they changed it on me at the last month, I wouldn't know, but theoretically it still is. And if you are the executive of your firm, and I just gave you this presentation, you'd say, okay, that's great. Of course, we'll do this. It's our regulations. But what does this really mean in practical terms? Can I just hire you to do it for me? I'll answer the last question first. And no, you can't just hire me to do it for you. Sure, you could hire someone like me to help you do this, but it affects your whole company. And either the whole company is engaged in it with executive support, or it's not going to work. It will be impossible. It won't happen. So now let's go through the same subway line again, but this time thinking about this in more practical terms. The regulation says we're supposed to have safety objectives in our safety management policy. That's a bunch of mumbo jumbo. Let's see what does that mean? How do we set good safety objectives? To set a good safety objective, the first thing we need to realize is that nothing is 100% safe. Like, who here has been in an elevator today? Anybody? Maybe no one has. Someone has. Okay.
No, I've
Yeah, you know what? Elevators are really, really safe. In fact, a friend of mine used to work for Otis, and in his training, they told him flat out, you work on the safest mode of travel there is. Nevertheless, I've read about people who've been killed in elevator accidents in New York City. They have so many of them that, you know what, it's very, very rare. I wouldn't worry about it myself riding an elevator. It can happen. They're a machine made by humans, right? Getting out of bed in the morning obviously had a risk. Like, people die in bathtubs. Staying in bed all day long has other risks, right? My point here is obvious stuff, but nothing's 100% safe. So if our policy just said, hey, everything must be 100% safe, engineering team, you need to guarantee that the odds of anything going wrong are 0%. There's no way to do that. We don't like it, but that's how the world is, right? So we can aspire to 100% safety, but think of that as your ceiling. That's where we want to go. Elon Musk wants to go to Mars, and he might reach that. 100% safety, we probably can't ever reach, sadly, but we can aspire to that. So our policy can certainly state that. But to reach this ceiling, you also need a floor. And that floor is a minimum level of safety that your company will accept as being safe enough. And we talk that way as a safety engineer. What makes something safe enough? Because you can always do better, right? And you state that safety as numbers. And so that's your policy, if it's done well from an engineering perspective, will actually have numbers, and the numbers you're going to have on tables are going to be the allowable probabilities of hazardous events of given severities. The allowable probability of hazardous events of a given severity. How often will the bad thing happen statistically? So how often will the bad thing happen? And if it does happen, how bad will it be? If this bad thing happens, will my finger get pricked with a pin, or will my finger get cut off, or my head get cut off? How bad will it be? And you take this as numbers, and this then sets the standard for your engineers to engineer against, and we'll see how this sets our entire safety policy, or it sets the entire requirements for your project. And if you're tracking with me at all right now, you're going to say, well, why can't we just make everything as safe as possible? Right? Because isn't that the goal? Make everything as safe as possible. So we're going to do a little experiment here. There'll be a little bit of audience participation. I want you to think about a local bus route that you know of, one you've ridden, one you've at least seen. And I'm more into trains, frankly, but the SMS policies are applied to all modes equally, microtransit, what have you. Local buses, express buses, whatever you're building, it applies to that under the FDA's regs. So I'm going to talk about buses. And I'm thinking of a local bus route it's on a 4-lane road that has a wide center median with trees in it, goes through city streets, has stoplights, that kind of stuff. You can picture any local bus route you want, though. Anywhere in the world, this will work just about as well. Conceptually, would it be safer for those buses to be in mixed traffic or to be in their own lanes? Just in general.
Own lane, I'd say.
Yeah. Obviously, being in your own lane is probably a lot safer than being with mixed traffic, right? So, okay, is it practical to go and put buses in their own lane? Because let's think about it. There's actually a technical term called a LARP, as low as reasonably practical, reduce the risk to as low as reasonably practical. There's a place for that, incidentally. There is a legitimate place for that, but it's not our core policy. If that's our core policy, I say, okay, is it practical for buses to run on their own lanes? Well, does anyone else do that? How many of you know some cities where buses run their own lanes? We can name a few, right?
Yeah, part of it.
Yeah.
Yep.
Yeah, London, Houston,
Yep.
Minneapolis, New York, Curitiba, Brazil. I mean, all over the place, right? Well, that's practical. So, okay, the bus goes in its own lane because that's our policy. We need to make it safer. Okay, well, is it safer for our buses in their own lanes to go through intersections with traffic lights or to go on grade separations over bridges in general?
Grade separation would be safer.
Yeah, right. It's been years, but at least in college, I remember looking up and learning that interstate highways were the safest roads mile for mile or passenger mile for passenger mile in the United States. Why is that? Well, no intersections. Even though you're going faster and laws of physics dictate there's more forces, you're more likely to get killed on a local street, apparently, than an interstate highway, if I remember. I looked up, mind you, it was 20-some years ago. If someone wants to fact check me, they're welcome to point out my error, but you kind of get the point. So, okay, we're going to put our buses on bridges in their own lanes. Well, that looks a lot like a bus rapid transit line. Now, BRT is a big buzz phrase. It's popular for everybody, just about in the US transit industry now, because I think it's cheaper to build. So if I'm going to go through all the effort to make a BRT line out of my local bus route, well, wouldn't a light rail transit line be safer yet? Any thoughts? Is LRT safer than BRT in general? The reason everyone's looking at me with blank stares is because it depends. It depends upon what you mean. Do I have street running LRT with line of sight operation? Do I have what's my bus? Does my bus rapid transit have any tech to it? How's that work? I'd have to analyze that to know. So let's skip ahead to something like the L in Chicago or the London Underground or the New York subways, those kind of systems. Is the L in Chicago safer in general than a light rail transit or a bus rapid transit line? And I would hope we'd agree, yeah, they move millions of folks. Statistically, they are considerably safer. I'm not saying the others are wrong, but if our safety policy says, hey, just make it as safe as possible, okay, I've now converted the 85 line Antoine in Houston into a subway or a elevated railroad, and that might be a good thing to build. But now I'm saying, not that I want to build it, but I'm required to by policy. You can see where this might not be the policy we want, right? I'll go a step further. If I'm going to build the L in Houston, well, how about Vancouver SkyTrain? That's fully driverless, unattended train operations. Been around since 1985. They've never had a passenger fatality that I know of. Or the Shinkansen, the bullet train in Japan. So impeccable safety records. RATP Line 2, there's driverless systems, I think, in Dubai now, and is it Kuala Lumpur? I'm forgetting some of the cities, but all around the world, you have some of these. Hawaii is building one that's kind of new. I think it's running now, I forget. Oh, why wouldn't I go and build that? Because that's safer, right? And at some point, you have to say, wait a minute, that would cost too much. We can't afford to put the bullet train as the only mode of travel. And while I'd love it if Houston or pick another city in this country or around the world said, hey, we want to build a driverless rail transit system, sort of like Vancouver SkyTrain, scaled to the size city they're in. Would you help us out? Sure, I'd love to do that. That'd be great. It'd be wonderful, even specifically for Houston, because yes, I am in Houston, Texas right now as I say this. But as good as that is, I wouldn't go and say and shut everything else down. Shut everything else down because it doesn't meet your safety policy. That's not a good safety policy. And that's kind of my point. That's why I'd say you don't have your safety policy make it as safe as possible, because there's no end. Like if all of us were to get on an airplane, fly to Tokyo and hang out on the Central Japan Railway for a while, and that's what they gave us unfettered access, I guarantee you we could find some idea that would on paper make even that system just this little skosh safer. Does that mean they ought to do it? I mean, maybe, but at some point you say, I can't afford to do that. And if I did try to do all that, I'd have no transport. You have to rip up all the local buses and for sure all the automobiles, right? No local streets anymore. Tear all of that up. Well, obviously, countries that don't have infrastructure tend to have a pretty low life expectancy. And the point of all this is to say it's reasonable that even though we don't like it, that things aren't 100% safe, it's perfectly reasonable and even moral for your company to say, no. What level of safety that we can afford to buy are we going to offer? Whether you're building widgets or high-speed trains or streetcars or horses and buggies, whatever, it's reasonable to say, what can we afford that's able to be done given current technology? And that's our level of safety. And it's not going to be wonton, but it's also not going to be 100% because you can't do it. So at this point, I want us to understand that allowable safety is stated as numbers, and how we use those numbers we'll get to later. But that's how it is. It's stated as numbers. I want to leave some time for questions. I have kind of three core parts of this presentation. We've gone through one of them. I guess four if I count the introduction with the FDA, but we've gone through one of the three core parts. So I might get all the way through the second core. The third one we'll save for another time if we choose to do that. Let's say we've defined our policy, and the policy, among other things, has our objectives. So we know what we're trying to achieve. The next step is safety risk management. And let's say we're starting from scratch, we're going to pick a system, a light rail line, and your city has no light rail right now, so you're starting from scratch. Their agency is a new agency made for this purpose. You would start out with a preliminary hazard analysis. And in my past, I have been somewhere where if you said this and such change needs a hazard analysis, if the people wanted the project to happen, they would say, oh, this is safe, we can just do this. If someone did not want it to happen, they'd say, yeah, we need a hazard analysis. Both of those perspectives are wrong. If your safety engineer is looking to start a PHA, they're trying to start the project, because the PHA isn't about go, no go for your project. I mean, in an extreme case, it can be if there's just simply no way to do it. Like let's say our project was mass transit by pogo sticks. Okay, that might be kind of hard to get through, but in general, it's not go, no go. It's how you define the requirements for your project. And SMS is kind of the ultimate holistic, proactive approach to safety that we've come up with so far. And this is the foundation of your house of safety. Without a good PHA, or if you're adapting an existing system into an SMS model, without a good initial hazard analysis, you're building on a wobbly foundation, and everything else, everything else becomes more difficult. If you think about it, SpaceX, Boeing, Airbus, some other space companies, they're all using, as far as I know, some kind of SMS system in their processes. And, of those, the ones that are having the most trouble, I can all but guarantee you, if they knew what they're looking at, they would rather go back to some of the earlier stages of some of their airplanes and make sure they had a really good foundation for how to proceed. And these are firms that know more about SMS than I do, frankly. So I'm not here to cast stones at them, but those are the kinds of things that you look at. So I'm going to go do some more audience participation. To do safety risk management, we need to do, I'll call it hazard identification, hazard assessment, and hazard mitigation. And a lot of people want to have your design, a good way along before you'll take those steps on a transit project. And really the best time to do this is in the beginning of the project. Let's pretend that we are, let's say we're going to build a bus rapid transit line somewhere. That's not really my recommendation for a city of my size. Let's say we're going to do it anyhow. And let's say it's going to be 20 miles long. We're going to run buses about every 5 minutes. And some of this will be in grade separations. You can pick any city in the world you want to think about. Based only on that description, what are some potential hazards that you can identify? Just call it out.
just intersecting with other traffic. So
Okay, so I have an intersection. I could hit other traffic. Okay, what other hazards do I have?
illegal use of the separated grade lane.
Okay, I could have trespassers either in other cars or on foot on my thing. Because I have buses in proximity, they could hit each other. Right, so bus on bus collision is a type of hazard, right?
Fatigue of drivers or competence or anything like around
right.
capability.
Yes, and fatigue and so forth is a thing in your fault tree analysis that could cause a crash, right? So the hazard's a crash, but one of the causal factors is fatigue or drug use and so forth. Those are all hazards, right? The other hazard I'm going to bring up is I could fall off the bridge. If I just build a bridge with no safety requirements, or what if I fall off it, get in a crash, fall off the bridge? So I'm going to focus for the moment to illustrate this on just these two hazards. Two buses hit each other and you fall off the bridge. So, okay, I need to go and use numbers, strictly speaking, to evaluate those. And the numbers in this case, this has become pretty obvious. If this was actually our project, we wouldn't live in this stage for even half a second. It'd be obvious if we knew what we were doing. But to illustrate it, let's think about how bus on bus crash and falling off the bridge as hazards with no mitigations at all would evaluate on this matrix. And by no mitigations, I mean nothing, as in anybody who wants to is allowed to drive the bus. You know, your mechanics play pool and for sure don't touch the brakes, the steering, or the tires. And just complete chaos, no mitigation. And that's ridiculous, obviously. But if that's what we had, no mitigations, or where would I fall? Well, let's look at what these categories in this risk assessment matrix mean. Your policy is going to define probabilities and severities. And this particular table is taken out of a MIL standard 882E US Department of Defense standard on system safety. And you'll see it has both qualitative and quantitative columns in it. But for the most part, for critical or catastrophic hazards, you're going to be using these quantitative numbers. That's how it's done around the world. And if you're in any building that's not just your house, you're probably very happy that someone applied real numbers when they calculated the loads on the beams and columns and the foundation that's holding you up, right? Your company could theoretically make any table they wanted to based on what industry you're in and what your risk thresholds are. Like I would imagine SpaceX probably has very different numbers here. I don't know, but that'd be my guess. The space shuttle certainly would have, had they been using an SMS system from the beginning. They weren't. That really wasn't defined in this way. Well, sort of. It wasn't. NASA maybe couldn't have used this if they wanted to back when the shuttle was designed, because it wasn't all there yet. But if they would have accepted a much higher risk than this. But this is a risk. And in qualitative terms, is it frequent? Is it improbable? And eliminated pretty much means you got rid of it. Like if I rip up my bus rapid transit line and I replace it with a monorail, oh, that's eliminated. All those hazards are irrelevant. Severity, that is fairly qualitative as it comes to injury, because that's obviously death is absolute. But you know, we have some categories that talk about how bad is an injury, what's your property damage. Different size companies will obviously have different risk thresholds on property damage, and the MIL standard does let you set this. Back to SpaceX, obviously they have a much higher threshold for just mere financial loss than probably any company that's ever been, and that's actually gotten them a long ways apparently. But they're talking property damage only. I don't know what their threshold is, but I'm guessing it's north of 50 million or more, depending on what it is and how much value they get out of the test, right? For more normal businesses or a transit agency, you don't want to set this number so small that you artificially increase the cost of your projects so much so that you're economically not not helping yourself, but these are the kind of things you'd think about if you're setting your policy. System disruption, that's not in the mill standard. That's something we came up with. I didn't even come up with it, but someone who trained me on this come up with this for potential use in Toronto, actually. And I don't know if Toronto ever adopted that, but the basic concept we had is that the value of your subway line or your streetcar or your bus line not being able to run is hard to quantify. So you'll set that up as if this bad thing happens, will service be gone for an hour, a week, a year, 1 minute? Now, what is it? And put some standards for that, and you can read the rest. But you put these two tables, your probability table and your severity table, and you put this against this table here. Let's think about a bus-on-bus crash. Can somebody die in a bus-on-bus crash? Obviously, yes. Death was in the catastrophic column, so I'm in this column. If I let the general public drive buses with no anything, no drug testing, no anything, no training, nothing, whoever I'm going to be, it's going to be one of these three cells. That's unacceptable, and that's obviously ridiculous. No one would do that. And the reason you wouldn't do that is because it's unacceptable. What does that mean? Well, that means we need to add some mitigations. And the kinds of mitigations people will jump to thinking about, if I say buses, are all going to be about autonomous buses, like the Waymo car or the Tesla, those kinds of things. I can't actually spec that for you right now. Nobody can. And every couple, 3 months, I meet someone who has some good, like a credible someone who either says autonomy is already here or who's involved in it and says, we won't have it in my lifetime. I won't live long enough. Like I've met someone who knows personally a guy who's involved with autonomous trucks driving between Houston and Dallas. And the driver sits in the passenger seat. I want to say I've seen one of those with my own eyes once. It looked kind of weird. Someone doing that, so I've been told, is I won't live long enough to see full autonomy with no driver. Is he right? I don't know. I can't expect that right now. So rather than jump into those kind of things, I'm going to start with more basic mitigations in this case. Like someone mentioned, we have training and drug testing and that kind of stuff, but the driver could fall asleep, those sorts of things. Well, obviously, in a transit company, you do have a drug testing program. Your HR department screens applicants who are hired. You put them through a whole bunch of training. They're given a certification at the completion of that training. Let's say there's a union contract. The union contract, among other things, labor relations and the union themselves are going to make sure there's some fatigue management awareness baked into how the company is allowed to cut runs for bus drivers. And even if you don't have a union, your company is still going to have some procedures for your schedulers, so that you're not doing things like the driver works for 18 hours straight, has 4 hours off, and does it again, because obviously the human body can't do that. All those kind of organizational mitigations, your maintenance plan and how that's followed up with, and this is for any mode, all of those are mitigations. So we would do those mitigations and would say, okay, having done those mitigations, are we now safe enough? And if I was a small city, I'm thinking about St. Cloud, Minnesota right now, with no inside knowledge at all about what their system's planning to do. But if they wanted to have a small BRT line on the campus of the college up there that maybe only had half a mile or a mile of 2-lane road with some buses on it, you know what, that might meet your safety policy. It might. If you were running 20 miles of this with buses every 2 minutes, probably you wouldn't, because the risk is too much because of how it scales. So let's say we need more mitigations, and I'm running about out of time, but let's say we needed more mitigations. And right now, all I have is a 2-lane road, partially on bridges. How can I mitigate bus-on-bus crash? Someone other than Andrew, maybe. I didn't go put everybody to sleep. I can't point at anybody in a video call. I like in-person stuff too. Adam.
Sorry, could you just repeat the question again, Ken?
Yeah, if I need more mitigations, now I have the drug testing, the training, all the
Yep.
kind of basic stuff you do because you're not insane. And I need more mitigations in my bus rapid transit line to protect against bus-on-bus collision or falling off the bridge. What would I do?
So yeah, I guess you could put some barriers up or whatever. You could put some sort of collision detection devices on, something like that. Some sort of so I'm thinking train world. So I'm thinking, how can you buffer in through sort of like in-cab signaling? So I don't know if there's some tech you can put on board around that side of things.
Okay, well,
Collision detection.
Yeah, let's start with barriers first. So you brought up barriers.
Yeah.
The easiest way to not fall off a bridge would be to put concrete barriers
Yeah.
up, probably, right? And
Yeah.
that's what we'd start with, and we'll go from there. If I put concrete barriers up, does that solve the problem? Well, it does, provided the barriers are strong enough for the task,
Right.
and provided that your bus's center of gravity isn't so high that you just roll over the stupid thing. So there's a little bit of systems integration to do, is my point. And the point is that you need to assess your mitigations to see if those mitigations cause more hazards. And in this case, they do. They're probably fairly easy to mitigate. Let's think about bus-on-bus collision. What could I do to prevent bus-on-bus collision? How about I put a barrier just in the middle, and that'll at least prevent
Oh, well,
head-on.
from that side, yeah, yeah.
All right, let's talk about head-on collisions for a moment. Let's put a barrier in the middle. Okay, does that meet our safety policy? Well, that introduces new hazards. For example, let's say I'm entering the busway from an intersection and some automobile hits my bus at high enough speed to steer the bus just a couple degrees to the left. And now, rather than clearing the barrier, it's going head on to the steering column and it impales the bus. So think about how that would work. What if the bus breaks down in the lane? How do I get the bus out of there? Because he's now blocking the lane. I have a railroad in essence, right? Do I need to bring a tow truck, back it in? All of those are things you think about. And someone might say, well, let's just go make the lanes twice as wide. So the bus breaks down, I can pass it. And then real estate folks say, wait a minute, that's going to cost too much, right? So what if I put a center lane in the middle and I put like rumble strips? Would that be good enough? You know, and what I'm doing here is the size of the project is going up by maybe even $1 billion, you know, up or down. But I'm in the early enough stages. I've not spent a lot of money. I'm just talking. And the better we work out these sorts of things, you're spending that effort when it's still cheap. Whereas once I have 1,000 sheets of drawings done, that's not cheap anymore. You're committed. The property's been bought. Your EIS statement is fixed. Your real estate, all these different things, right? So the beginning is a time to think about it. And yeah, if I was actually building a BRT, I don't think I can do full autonomy, but I imagine lane keeping tech is probably there, and maybe even rear end collision prevention is probably there. That we can probably buy off the shelf, or at least for a fairly known risk, financial risk and time risk, have someone adapt that for me. But even those you would put back through your process of assessment and mitigation, and your hazard analysis by the time you're done will account for all hazards, all credible hazards, and the mitigations it specifies are the sum of everything: design, procedure, training, maybe construction methods, etc. Everything provided, those are your mitigations. And the sum of all of that then sets the requirements for your project. And where we go from here is probably another whole talk in a future month. And this was just meant to be the overview. Obviously, no one's going to take this training in March and go to pick your favorite company with 2,000 people in it and, hey, we're doing SMS tomorrow. Boom. That's not what I'm trying to communicate today. But with the portion I've given you, is there I guess any questions, any feedback, anything you'd like me to dive into a little more if we talk again about this?
Ken, just before anybody jumps in, I see Dennis has got a question, but yeah, we're kind of up on the hour, but if everybody's okay, we'll spend another 10 minutes to cover everything off. And You fill a lot in that space, Ken. So Dennis, did you have a question for Ken?
Yes, I do. And Ken, thank you so much for all of the content. It was very interesting. And I have a question related to technology, and it's kind of a two-folded question, I'm afraid. And the first question is, what are some of the digital tools that an SMS typically has? For example, I'm thinking about communication, risk mitigation, auditing. And then in terms of technology, in your experience, would you see SMSs connected to operational systems such as WMSs and transportation management systems? And I am thinking, if there is connectivity, can a risk identified in an SMS prevent from operational actions to happen down the network?
Yeah, if you're doing a full SMS process, one of the outcomes of your hazard analysis is going to be operational procedures. If you think about it, eventually everything falls through procedure eventually. I talk about the 3 E's still, some of us, engineering, education, enforcement. And while I like to start with engineering in general in a hazard analysis, the reality is, even if I have the highest tech train there is, let's talk about the Shinkansen, their maintenance standards and who does that and how they do it and how they audit that is critical. And if you didn't have that, you wouldn't be able to function. So it comes down to the operational policies all the time. And I don't know if the Shinkansen uses SMS per se, but if you did format everything they do into an SMS system, then you would come to that point. In terms of tech, the biggest thing you need to do SMS is a document management system, a document control process. And a lot of agencies think of document control as like a database, and a database helps, obviously, unless you're like tiny. A database is useful, but what you really need is the management processes behind that. And if you have the management processes to control your documents, you're going to see, okay, I need a database to house stuff. And that database needs these kind of principles. So the biggest piece of tech that would apply to SMS anywhere would be what you're using as a database system that is organized by your document control function. The next thing you would need, and I'm talking kind of in general terms, and Jennifer might know a ton more about this. If you're doing fault tree analysis or anything that's not trivial, there's software out there which helps you math-wise that way. Jennifer, you've probably done more with SMS than I have, given how Andrew introduced you. Go ahead. Yes, I think she's trying to say something.
I'm not sure. I think it could have just been some background noise there.
Fair enough. Does that answer the question?
Yes, thank you very much.
Okay.
Okay. So, Asiri.
Yes, thank you so much for the nice presentation, Ken. So the question is for me is what are the let's say the critical challenges you face when you implementing such kind of a system in a existing like a BRT or LRT system? Like, what are the challenges you face? Like the main challenges you face
when you're implementing it in what kind of system?
Like the existing system, like not a futuristic one, like the
existing system.
Let's say,
yeah, that's that is a tough challenge. The first thing I've recommended, I've tried to get one system to do this in my career, had exactly that problem. And I said the first thing is, I think your policy probably needs to give yourself permission not to analyze everything. Like, I couldn't pick any system. I'll pick somewhere I'm not involved in, just so I don't share inside info. But let's say we were, I don't know, Minneapolis, Minnesota, or better yet, I'll pick on Portland. Let's say I'm in Portland TriMet, and let's just pretend I never worked with them. Pretend that we need to do this from scratch. If I then turn around and say, okay, my safety policy requires a 10 to the minus 9th probability against a fatality, the 1 in 1 billion operating hours between fatalities. And I've been in a system where that was originally the standard, 1 in 10 to the 9th against fatality. Well, obviously a street railway can't achieve that with today's tech. That's ridiculous. The cars, I mean, local buses don't achieve that. I mean, that's that's probably even better than aviation style safety. That's incredibly hard. So you need to set some realistic thresholds, but then you also need to go and give yourself permission to say, okay, this line has been here, whether it's a local bus or light rail or whatever you got, monorails, what have you. It's been here for a long time. We're going to declare that this line is safe enough to meet our policy for now, unless and until we have a need to evaluate it further. And because you have a crash rate, that'll force you to evaluate it. But you then use that part of your policy to kind of shape the freedom you have. You need to give yourself some permission to say, okay, I don't know everything. We built this 10 years ago, 100 years ago, 150, 200 years ago, even if they were like one of the older freight railroads, and say you wanted to do this. Yeah, you can't. So you're going to start somewhere. You're going to start with if you're going to start analyzing your whole system, but you're going to pick an aspect of it that you're going to bound, and your hazard analysis would probably have some assumptions in it that you don't even prove, which would be very non-standard, but you're going to justify why you're doing that. Let's say when I analyze a signal system, well, and I haven't analyzed my rail vehicles, so that braking curve on that rail vehicle is important. I can at least myself foresee a world where you might, as a temporary thing, say, okay, we're going to assume this is right, even though we haven't validated it. We'll accept this signal system. However, we have these open items that we're giving ourselves X time to evaluate further, and probably you'd put it out for probably not much more than a year, but that would then give you a year to analyze your vehicle's braking systems. And say you had lots of different rail vehicles, that might not be enough, but at least 10, 11 months later, you recheck in, are we still comfortable with this? And you use processes like that to buy yourself time. I would think like a system with I'll say 10 to 50 miles of light rail transit and several hundred buses would probably be 5 to 10 years minimum of concerted effort before you can say every last hazard that we know of in our operation has been identified.
Yeah. Thank you so much. Yeah, thank you.
Okay. So I'm not sure if we got any other questions. We've got a couple of thank yous and plaudits from the folks that have had to leave, Ken. I'll leave another couple of minutes if there's anything else. Anybody has a question, but otherwise, so Ken, thank you so much for that presentation. I have to say, really interesting. It's not an area that I've really given a great deal of thought to, and I think for probably everybody in here realize it's something we should all be aware of. I really think we should get you back to really finish the third phase as well, and we can incorporate that in a future forum. But well,
thank you.
Thank you for your time. We have recorded this. We will be posting it on our CILT website, or YouTube channel. So please, if you've got friends, colleagues that you think will find this useful, I'll be sharing that link tomorrow once we've got it uploaded. So feel free to share that and encourage them to get involved with CILT and get more of this kind of content. So thank you again, Ken. Really, really appreciate that.
Okay, thanks everyone. Have a good night.
Yes, good night, everybody.
Thank you. Good night.